Does the type of bonding in a chemical compound affect its relationship with conductivity? I'm André Isaacs, and this is Ionic and Molecular Compounds. In order to understand how bonding impacts conductivity, we will use this apparatus. When we turn on the power, nothing happens. But if I connect the two electrodes, suddenly the bulb lights. Shazam! This is called a conductivity apparatus. It allows us to test whether something conducts electricity or not. Let's grab some common substances and see what this tells us about their properties. First, let's just test some water. If I submerge the electrodes in a beaker of deionized water, let's see what happens. Ooh, the bulb does not light. Well, that's because water does not conduct electricity very well, at least not well enough to light this bulb. But in the movies, they are right. You do not want to be in a pool when lightning strikes. Stay away. Next, let's test a simple sugar, glucose, which is a molecular compound. It exists as molecules of C6H12O6. If I submerge the electrodes in a beaker of glucose and let me turn the light on, nothing happens. And what this is telling us is that the solid glucose doesn't conduct electricity at all. Glucose molecules are neutral. Maybe that's the problem. So let's try something else. Let's try something ionic. Maybe we'll get a different result. So everybody knows table salt. I have some, sodium chloride here. I use way too much in my cooking. It is made up of sodium cations and chloride anions, and I'm gonna put some into this beaker. So I've put the electrodes in the beaker of sodium chloride, turn the lights on, and once again, nothing happens. I think I'm seeing a trend here, or glucose or salt, neither of them conduct electricity. But this doesn't make sense. Sodium chloride consists of charged particles, not neutral molecules like glucose. So what's happening? Why doesn't this conduct? Of course, the ions and molecules are relatively static in the solid. So dissolving the solids in water allows the particles to move around. Maybe just maybe this will help. Now, if I add water to the solid glucose, here we have a nice solution of glucose in water. Turn the light on, still no conductivity. The electric current still doesn't flow if the particles are neutral, like the molecules in C6H12O6. So in this case, the bulb doesn't light up. Substances like glucose do not conduct electricity in aqueous solution, and we have a name for them. We call them non-electrolytes. Now, what if I add some water to the solid sodium chloride? If I do that, the salt dissolves in the water, and woo, slay, we figured it out, it lights. Dissolving the solid in water allows the particles to move more freely. In this case, as the sodium chloride ions are charged particles, it allows our current to move, closing the loop and lighting up the bulb. Substances like sodium chloride, which conduct electricity when dissolved in water, are called electrolytes. Now, let's see what happens in a sports drink, which has a lot of electrolytes. And as someone who plays a lot of tennis, I need it for energy. So I'm pouring this in here. And as you can see, it doesn't light. It does, a little bit. So this sports drink has some electrolytes in it, not a lot to light up the whole bulb, and that's good because I don't want hypertension. But you can see that this sports drink actually has electrolytes present in it. So we can distinguish between types of compounds on the basis of their conductivity. This is the difference between covalent molecular compounds and ionic compounds. And there you have it.